Hi, this is Mrs. Baston, and today we're going to review how to predict products in a chemical reaction and then how to write out the complete balanced equation. So we're going to go through 10 examples here that cover all the different types that we've talked about in class. So this first one is aluminum hydroxide decomposes. So like we talked about, the best thing to do is first try to figure out what kind of a reaction it is, and then that will help you predict the products. So for this particular one, the description gives it away. So this says it decomposes, so we know that's a decomposition. Now for decomposition reactions, remember, there are these reaction patterns that we have to memorize. So these statements that are in yellow here, you have to have memorized in order to be able to come up with the products for a decomposition. For a decomposition, it doesn't just break back apart. So decomposition, depending on what type it is, there are special products that are produced. So like I said a minute ago, you have to memorize those in order to know what your products are going to be. Okay, so we're going to start out with the aluminum hydroxide. So aluminum is a +3. Hydroxides, a -1. So that means I'm going to have AlOH3. And then it decomposes. Okay, so now we have to come up with the products. So for the products, I'm going to look at what type of a substance it is. So for this one, it's a metal hydroxide. So according to my pattern, the metal hydroxide decomposes into a metal oxide and water. So the metal that it starts as is going to be the same metal that combines with the oxygen. So since my metal in this case was aluminum, I'm going to have aluminum oxide as my product. So when I come to the product side, I have aluminum that's a +3 and an oxygen which is a -2. So remember we said when you go across the yield sign on the other side, you have to refigure the charges when you're writing down the chemical formulas. So these crisscross down and you get Al2O3. And then my other product, like it tells me up here according to my pattern for a hydroxide, is H2O. So this would be my equation. The last thing I would have to go is to go back and balance it. So to balance this one, I need a 2 in the front, and then I need a 3 in front of the water. So then this would be your complete balanced equation for decomposition of aluminum hydroxide. So for this next one, we have ethanol burns in air. So to figure out what type of reaction this one is, ethanol, I give you the formula for, so if it's something we don't know how to write out the formula for yet, then I will give that to you. So this is a hydrocarbon and it's burning in air. So that means this is a combustion reaction. So for ethanol, we know it's C2H5OH. And remember we said when something burns in air, that means it's reacting with oxygen. So I'm going to put +O2. And then combustion reactions always produce CO2 plus H2O. And again, like we talked about, we're assuming complete combustion, so we're going to have CO2 as our product plus H2O. The last thing on this one, you have to go back and balance it. So to balance this one, I need a 3 here, a 2 here, and a 3 here. And I'm not going through all the steps of balancing because I know you guys already know how to do that. Okay, my next one, lithium metal reacts with silver chloride. So on this one, I have an element reacting with a compound. So that means I'm going to have a single replacement reaction. So lithium metal is Li. It reacts with silver chloride. Silver's a +1, chlorine's a -1. So those would be ones which we wouldn't have to write. And then to figure out what the products are, I have to first figure out what is the lithium going to replace. So lithium is going to replace the one that has the same charge that it would form in the compound, or you can think of it as it's going to replace the one that's most like it. So in this case, lithium is a metal, silver is a metal, so those are the ones that are going to switch places. So the silver comes out, and then the lithium combines with the chlorine. Just like we said before, we're going to redo the charges. So +1, -1. So for those, crisscross and they would cancel out. So I have lithium plus silver chloride gives me silver plus lithium chloride. Okay, last step would be to balance it. And if you look at this one's already balanced. So that would be your complete final equation. Our next one, sodium hydroxide reacts with hydrochloric acid. So on this one, I have a compound and a compound. So that tells me this is going to be a double replacement reaction. So sodium hydroxide, Na is a +1, hydroxide is a -1. It reacts with hydrochloric acid. So remember, hydroacids are binary acids, which means it's just H in the element. You still do your charges on these, so this is a +1, -1. And then just like we did before, they're going to switch with the one that's most like them. So like we talked about in class, what I recommend doing is whatever is first in the reactants, you leave it first in the products. So I'm going to leave sodium first, and I'm going to leave hydrogen first. And then I'm going to switch the chlorine and the hydroxide. So Na is going to combine with the Cl. So Na is a +1, Cl is a -1, so those would cancel out. And then the H would combine with the OH. Okay, so if I rewrite this out, I have NaOH plus HCl gives me NaCl plus HOH, if you notice, is the same as H2O. Again, this one is balanced the way it is, so this would be our final equation. Okay, our next one, potassium reacts with iodine. So potassium is an element, iodine is an element. So this is going to be a synthesis reaction. So potassium plus iodine. Okay, now iodine, notice we wrote as I2 instead of just I by itself. So iodine is one of our diatomic molecules. So anytime you have a diatomic molecule all by itself in a reaction, it has to be written with that 2 to show that that's how it's present when it's by itself. So then on this one, the only thing that can happen here is those two can form a compound together. So K and I are going to combine. K is a +1, I is a -1, so those would cancel out. So K plus I2 gives me Ki. Last step on this one would be to balance. So I would end up with 2K plus I2 gives me 2Ki. Next one, this is another decomposition reaction. So that means I brought back up my decomposition patterns here so we can look at which one it would be. And again, these have to be memorized. So now I have silver chlorate decomposes. So this is a metal chlorate. So silver chlorate is Ag, which is a +1. Chlorate is one of our polyatomic ions, ClO3, which is a -1, and it decomposes. So when this decomposes, it turns into a metal chloride plus oxygen. And like we said before, the metal is going to be the same as the metal in the initial compound. So the metal chloride is going to be Ag, still a +1, Cl, which is a -1, and then our oxygen, which is O2. So then, last step is to balance. So for this one, to balance this, I need a 2, and a 3. So then that would be your final equation. Okay, our next one, aluminum reacts with copper 2 chloride. This one, I have a metal and a compound, so this is going to be single replacement. So aluminum by itself, copper 2 chloride. Remember, if you have a Roman numeral, that tells me the charge on the initial element. So that means copper is a +2. Chlorine is a -1. So this is going to be CuCl2. And then just like we did before, the aluminum is going to take the place of the one most like it. So aluminum's a metal, copper's a metal, so those are the ones that are going to switch places. So that means copper is going to come out by itself, and then aluminum, which is a +3, is going to combine with chlorine, which is a -1. So here's my copper. When I crisscross those charges, I get AlCl3. Last step is to balance. So for this one, I need a 2, 3, 3, and a 2. And then that would give me my final balanced equation. Okay, this one, sodium phosphate reacts with zinc chloride. Sodium phosphate is a compound, zinc chloride is a compound. So sodium phosphate, sodium plus 1. Phosphate's a polyatomic. PO4 is a minus 3. So this is going to be Na3PO4. Reacts with zinc chloride. Zinc is a plus 2. Chlorine is a minus 1. So that's going to be ZnCl2. Okay, this is a double replacement like we said. So I'm going to do the same thing I did before. I'm going to put sodium first, and then I'm going to put zinc first, and then I'm going to swap out what they're combined with. So now sodium, still plus 1, is going to combine with chlorine, which is a minus 1. So that gives me NaCl. And then zinc, which is a plus 2, is now going to combine with the phosphate, which is a minus 3. So I get Zn3PO4 2. Last step is to balance. So I have 2 of these, 3 zinc chloride, 6 NaCl, and then 1 zinc phosphate. So that would be your final equation on this one. Okay, another decomposition reaction. This is the last type we haven't done yet. Now we have a carbonate decomposing. So potassium carbonate, K is a plus 1. Carbonate's one of our polyatomics, that's a minus 2. So K2CO3 decomposes into a metal oxide and CO2. So the metal is going to be the same as the one we started with. Metal is going to be K, which is a plus 1. Metal oxide means it combines with oxygen. Oxygen's a minus 2. So this is going to be K2O. And then my other product is CO2. Last step is to balance. This one ends up being balanced the way it is. So that's your balanced equation. Okay, our last one, ammonium phosphate reacts with cobalt-2 nitrate. Compound and a compound, so this is a double replacement reaction. So ammonium is a polyatomic, NH4, that's a plus 1. Phosphate, PO4, is a minus 3. So this is going to be NH4, 3, PO4 when we crisscross charges. It reacts with cobalt-2 nitrate. So again, the Roman numeral tells me the charge of cobalt. So cobalt's a plus 2. Nitrate, NO3, has a charge of minus 1. So that means I have CO, NO3, parentheses 2. And then since this is double replacement, we're going to leave whatever's first in the products. And then I'm going to switch out my second part. So now the NH4 is a plus 1, combines with NO3, which is a minus 1. So I have NH4, NO3 is my first product. Cobalt's still a plus 2. Now it's combining with phosphate, which is minus 3. So then I have CO3, PO4, parentheses 2. Last step is to balance. So I would need a 2 here, 3 here, and then a 6 here. And then the cobalt phosphate just gets a 1. So final balance equation for double replacement.